Hi everyone. So at Virginetic, we are working on a smart molecule that can help detect cancer earlier and can also guide the surgeon during the tumor removal with a greater precision. But before we begin our work, I would like to start with a quote that deeply resonated with me during my early career. And I want you to take 5 seconds to just reflect on it. These words actually hit me very hard. And this also reminds us that the cancer research is not just about science, it's about the people, family, and urgency of detecting cancer earlier, before it becomes devastating. And it also raises a powerful question: why early detection is so important? To answer that, I would like to step back and talk about this scale of challenge. In every year, about more than 20 million cases of cancer were diagnosed worldwide, and that number is going to increase by 30 millions. And it's not about the cancer, it's difficult part is not about cancer, it's when we actually find it. Most of the cancer we find at the late stage, like in 60%, when at that stage is difficult to treat. And even after the treatment and the surgery, cancer can come back, even up to 50% of some of the cases, because the tiny cells are left behind. So the challenge is clear, how can we detect cancer earlier, and how can we guide doctors see it clearly so that no tiny cells left behind. At present, the doctor heavily depend on this clinical imaging technology, and some of you already know, like CT scan, MRI, and ultrasound. They are the great imaging tool, but these two share a limitation. They can only detect a tumor size of 1 cubic centimeter, close to 1 sugar cube. So if you have something below, that can't detect. So by the time we detect the tumor, it already well established. To visualize this limitation, let's pretend you have two particles. Consider this is the tumor which is size of more than 1 cubic centimeter, that is detected by the current imaging technologies. But what if you have very tiny molecule, tiny size of tumor? That's what we are trying to solve. If you also look at this tumor growth curve, then initially the tumor starts with few cell lines, where initially its tumor is small and invisible. Over the time it grows larger and make it visible by the current imaging technology. Our target to detect this invisible area, we are trying to detect it within this window. So now the question is, how would we detect it? That what comes our research. In our lab, we develop the tiny molecule that act as a light switch. In healthy cells, upon uptake, it's remain dark. But in cancer cells, upon uptake, the target enzyme triggers some biochemical event, and that lights up like this flashlight. So in cancer cell, if you look at this, in the healthy cells, it's remain dark, but in cancer cell, it lights up. This is our probe image. So beyond advancing the scientific knowledge, our research holds profound societal implication. Imagine a world where the cancer is being detected early, so it can provide a huge light of hope. And also, the early detection can also reduce the huge emotional and financial burden of the family. Our research had also potential, to improve the healthcare accessibility, actually the underserved region, and also can help the doctor to identify the boundaries of infected cell over the healthy cells. So I think through our innovation, this is not about the science. We are trying to bring out some solution which has a healthcare implication, and we are hoping through the early detection in the surgical precision, we are moving closer to a future where we are trying to replace the fear with hopes, and every diagnosis become an opportunity of life. And with that, I would like to thank you all for your kind attention.